Hey, good morning. This is Tech Mornings with the Tech Prepper, Episode 7, Deploying Peregrine to Google Kubernetes Engine Part 3. This may be the last video, but in this video we will cover deploying a 3-pod application stack to GKE with Helm. And as part of this deployment, at the very end of the video, I have a clip whereby I had to resize the size of the cluster from 1 node to 2. So please stay tuned to that. And if you're listening this far, I may stop the series here and not go over the SSL termination. We're not getting a whole lot of feedback on these videos or views, so my preference may be just to switch back to the normal prepper videos since there seems to be more of a following there. If you do like these tech series, please let me know, and I may consider doing continuing this series. All right, let's go ahead and start our first Helm deployment to our cluster. One thing you'll note is that the cluster size has changed to 2. I was unable in a dry run earlier to deploy the 3-node stack or the 3-pod stack with just 1 cluster node. And if you are curious on how I solved that problem, I'll include a clip at the end of this video for anybody who's interested. All right, let's get started. So the first thing we need to do is move back into a working directory on our local system. And we need to go ahead and check out the Git project that has Helm. So just clone this repository. It's peregrine-cms/peregrine-k8s-explore.git. And this is a working repository. It's not quite ready for prime time. The next thing we need to do is move into this peregrine k8s explore directory. And there is a new feature branch called feature contentrestructure. And at this point, the Helm chart is actually available here, so feel free to peruse this. I don't know if I'll have time to do a video to go over how Helm is laid out. So let's just go ahead and run the command. And for this first run, all we're going to do is run it without complicating it with SSL termination. So this is going to provision 3 nodes, a Peregrine stateful pod and 2 Apache stateless pods, as well as the services required. And then Google will actually provision IPs for both of the Apache pods. And the way this works is it's basically Helm install. And then when we want to give a name for the release, I'm just calling this one R1. And then there's a folder in this project called Peregrine. If this was hosted up in a Helm repository, you can actually specify the full path. We do have it hosted in, we do have a repo for Helm. It's actually tied to this GitHub project through GitHub pages, but we're not going to go into that now. We'll assume that we'll just use the working Git project at the moment. And then we have to set a handful of settings. So the first one is this peregrine.storage, and this will define the amount of storage you want to allocate for the persistent volume for your Peregrine storage. I have it set to 50 gigs. When we went through the cost calculator, this ran us about $2 per month. The other one we have here is the docker.peregrineImageTag, and I have set this one to issues 93 2020-0413 R1, and this is just to instruct Peregrine on which Docker image to download for Peregrine. This is about 5 days old. There's a newer version I'm working on pushing that will have some new updates, but for demonstration, I think this is fine. The next one is peregrine.site, and this needs to be the name of the Peregrine site that we will be creating after it's created. So there's some encoding rules, but I think right now when you create a site, the convention is everything is lowercase and then spaces are normalized to underscores. And then there are a couple of Apache settings. There are some environment variables that are patched to the Apache pod through environment variables, and those are actually propagated into the vhost configuration. So apache.liveDomain, this is obviously now my external facing domain, thetechprepper.com. And then the second one is what we're calling the Apache stage domain. So this is where you will actually do your editing. And I've called this one stage.theprepper.com or stage.thetechprepper.com. So let's go ahead and run this command. And I notice that I'm starting to get this transport is closing error. I'm not exactly sure why it's doing this. I'll have to research it. In the first run, what happened was it turned out we didn't have enough resources to support the 3 pods. But it is going through and creating it. So if I do k get pods, you notice here that it's actually trying to spin up an Apache pod for live, an Apache pod for stage, and then the Peregrine pod itself. It will also go and get the services. And you'll notice here we have a handful of services. So the first one is Apache Live, and this will proxy all requests to Peregrine on the back end. And this one has a bunch of it's basically not a pass-through, but it blocks a lot of the admin pieces and has a lot of security there. And since we're only running one Apache or one Peregrine instance, we're also proxying stage through. So stage is pretty much a straight proxy. There's not a whole lot in the way of rewrite rules. I think the other important point to note is that with Google's cloud platform and it being hosted in the cloud, it will actually provision a physical hardware load balancer. So for me, there's no need to deploy an ingress here, which is quite nice. And then these are the IPs we'll publicly be able to hit here in a minute. And I believe, yeah, so that's pretty much it on this side here. So what we really need to do is wait for 2 things. We need to wait for this remaining service to get assigned an external IP address on Google's cloud platform, and we need to wait for all of these pods to go into the ready state. And just to show you that everything you can do on the command line, you can do in the console, we can go ahead and click on workloads, and you can actually see now that it looks like everything came up. One thing to note, sometimes you'll notice that if you catch it just right, that the Peregrine pod will have been fully initialized. It'll be 1-1/1, but then the pods will be 0-1. And the reason for that is that there's a health check on Apache and Stage, and they require that Peregrine be available, since that's the actual health check, is to actually see if the proxy is working. And you can also see services here too. So let's go ahead and hit live. Actually, before we hit live, let's go hit stage. So we're now on the public internet. This is fully open to the world. So the first thing I want to do is log in and change the password. So just navigate down to Composum. Navigate to users. Expand these nodes till you find the admin user. Click on it, and then there's this little key icon, and change it to some new password. All right, so at this point, even though we don't have HTTPS, that may be another video, I'll talk about that in a second. We're now able to go ahead and manage Peregrine, and we've got the user, the username or password change for the admin user. All right, so let's take a look at live. And live will actually return a 404. And the reason for this is this site does not exist yet. So when we had created our site via Helm, you notice that this site name was the one we created, the_tech_prepper. So for this to resolve, you actually need to go in here and create that site. So we'll do theme clean flex. I will do warm tones next, and I will do the tech prepper. So this is the value you need to make sure will be available. Click next, finish. Pages, and just to assure you this is working, I'm going to edit the index page. I will drop on a very quick rich text component and put in a comment, yay, we're on GKE. We'll save that, and then we'll go back and refresh this page. All right, guys, so I hope you've enjoyed this video. Really, that's all there is to get Helm working and deploy to GKE. The next thing we're going to do is I'm going to destroy this application or this release. So the way we're going to do that, I believe, is Helm, del for delete, -- purge, and the name of the release, we called ours R1. And this will go through and delete all the resources except for the persistent volume. I haven't got to a point yet where I can actually get Helm to delete a provider-specific storage. So if we run now get pods, you can see now they're all in the terminating phase. If we get the service listing, it looks like it has already deleted the services. And what that means now is if I refresh this page, actually let's go ahead and hit it in a different browser so you can see it. Basically, the site's gone at this point. And then we'll double check now the pods, and they're all gone now. We still do have our cluster running, so we do k get nodes. It's still available to do another deployment out to it. There is one thing I'll note. So we do have to remove the persistent volume claim. So if I do k get persistent volume claim, you'll notice that there is 150 gigabyte storage. Google will charge us $2 per month based on this size. So all we want to do is, I think it's k delete pvc and then the name. And it's been deleted. And we can confirm that. So at this point, we can double check the dashboard. So let's go ahead and refresh here. Yeah, so all the services are gone, all the pods are gone, all the storage is gone. So hopefully you've enjoyed this video. I think I may stop this series. I haven't decided if I'm going to record the more complicated Helm piece that does the SSL termination, provisioning the hardware load balancer, and does all that work. It's not too different than what we're doing here. In fact, it's just a couple of extra commands. The challenge is I'm not getting a whole lot of feedback, and these videos do take quite a bit of time. And just based on my schedule, if I had to record something, I prefer to do the prepper videos. So if there's massive resistance, I may go ahead and do a video. So let me know in the comments if there's interest. And I'm hoping it's more than 10 people that are interested. At any rate, guys, this is the Tech Prepper. Be strong, be safe, and think about experimenting with GKE, Helm, and Peregrine. All right, so I tried to do a dry run of installing the stack with Helm, and I ran into this issue of the pods being unscheduled. And the first indication that it failed was when I ran Helm, it basically blew up. It did try to create all the resources. So if you take a look at get pods, it did try to go and create the live pod, the stage pod, and the peregrine stateful pod, but you notice they're not in the ready state. So to quickly take a look at what was going on, we can do k describe pod, and we'll look at what's going on with the peregrine pod, for example. And then as you notice here at the bottom in the events, there's a warning that indicates there aren't enough nodes available. And if everybody remembers correctly from the last video, we had only done a single node cluster. So what I'm going to try to do, I've never had to resize a cluster. I've always started with at least a 2 or 3 node cluster using this Helm deployment. Let's take a look at how we can resize it with gcloud. All right, so all we're going to do here is basically use gcloud container cluster resize, and the name of our cluster, mine is the tech prepper 1, and then the node pool. We did not create a custom node pool, we just used the default, and I'm going to specify the number of nodes now as 2. This will increase the cost and cut down the time I can actually run the platform, but again, this is valuable information for me. It'll still be free for the short-term future. So, okay. Why did it roll back my bash profile? Okay. So at this point here, we're just going to need to confirm that we do want to resize the cluster, and let's see what happens. And I'll toggle back and forth between the terminal window and the console. Let's refresh. It looks like the cluster size is still 2, but let's click around. And at the bottom, I believe they have the default pool. You can see here it's updating. Oh, cool. So it looks like it added our second node. So at this point, let's double check the pods here really quickly under the workloads. We'll do the same thing from the terminal. And you can already see here that the Apache Live pod and the Stage pod have already are up and running. And now it looks like it's also allocated the Peregrine stateful node. So on our side, we can do a few things. So let's verify the cluster. We'll do get nodes, and now we should see 2 nodes. Perfect. And let's do get pods. And we can actually see both our pods here. And you notice the status for the stateful pod is an init. It's probably pulling down the Docker image and also going through the process of, there's like an init step that it bootstraps the repository so that we can actually use it as a stateful pod. So let's do kdescribe pod and then our pod name, and we can see what's going on here. Okay, so this is perfect. So this was the error we were seeing earlier where there weren't enough pods. And then it looks like this was some network communication issue while the second node was coming on. And then it looks like we were able now to get, this pod was able to get allocated to a node on the cluster. And then it looks like it has gone and provisioned the persistent volume claim. And as I said, it looks like it's pulling the Peregrine CMS issue 93 Docker image for us. I wasn't planning on showing this, but I think this was actually pretty cool for demonstration.